All right, sounds good. Yeah, well, thanks for having me. I've come to a couple of these. There's always a great group, so excited to talk with you guys today. Yeah, my name is Ryan. I'm from Indiana originally. Been doing software engineering for about like 6 years now. And yeah, I guess as of about a year and a half ago, my friend Dimitri, who's also in here, and I started a open source continuous profiling project called Pyroscope. And I can paste some links in the chat, I guess like at the end, or I guess right now I can at least paste the link to the slides from today. But yeah, basically we started it and have been, while it's not Python specific, Python is one of the most popular languages that we have people using for Pyroscope. And so, yeah, I'm going to talk a little bit about profiling, how it works in general, I guess what it is. And yeah, we built a custom storage engine. So I'll talk a little bit about the algorithm that we used for that. And then also sort of what we did to turn everything into a Python package and I guess, yeah, package it up and make it so that people can use it easily. So let me go ahead and share my screen. Let's see, where is the share button? Okay. All right. I assume you can see my screen now. Yeah, so I will go ahead and get started. Let me move some stuff around. Okay. Yeah. So basically there are a lot of profilers out there and profiling comes in a lot of different forms. I'd be also generally interested, maybe paste in the chat, I can read them later if anybody here has used any profilers, particularly any of these. I would say the most popular ones that I've seen specifically in the Python world are C profile, and then obviously just time and time it are sort of quick and easy ways to profile code. But there's a couple of other ones that exist out there as well. PySpy is pretty popular. It's the, I guess, sibling of RBSpy. Although it profiles Python code, it's actually written in Rust, but I will talk a little bit more about that later. But yeah, basically this is kind of what I would say a common output. It doesn't always look like this in a flame graph form. A lot of times you'll get it more in just like a text form where it breaks down sort of, what is, yeah, I guess, yeah, what's going on in your code. But basically from a high level, Python just tells you, profiling just tells you what your application is doing and how it is using resources. Continuous profiling does that over the axis of time so that you can see how that changes over time. So yeah, so this is just kind of a picture of what a flame graph is. And so basically how you read this is that a flame graph is sort of like a nested pie chart. And essentially it will tell you, like I said, which parts of code are consuming the most resources. So that could be CPU, that could be memory, or other similarly formatted data where it's in somewhat of a tree structure. So this is kind of an abstract example that somebody made, Julia Evans, but basically in this case, you would, if these were functions, function main would be calling panda and alligator, and then function panda would call bamboo, and so on and so forth. And then these percents are the percent of time that the application or the server or whatever is running is spending in each of those different functions. You also might be familiar with, I guess, yeah, perf is another example that does profiling as well. But yeah, that's basically just kind of an abstract example of how it works. And And so I'll show a more, I guess, show a more, practical example a little bit later. But before getting into that, I wanted to talk about the two different types of profilers, or the two main types of profilers. So you have your kind of standard profilers, which are what people are most familiar with, I would say. I guess historically, a lot of standard profilers, they're fairly easy to sort of understand. You essentially basically like report what's going on in the program. They're slightly more accurate. So, you might have something at the beginning of a function, at the end of the function, that sort of like starts the timer, stops the timer. And you can basically hook into the different class or method invocations to figure out what's going on. The problem with those, I would say, or something that makes them harder to use in production versus using them when you're just like debugging something or running something in an ad hoc way, is that when you're doing that, there's a lot of performance overhead because you're having to hook into every single function or method call or whatever it is. And so that just makes it hard for someone to use that in production continuously. Sampling profilers, on the other hand, are a little bit different. They allow you to sample the stack trace at different frequencies. So, for example, you could sample every 100 times per second, or that number is configurable, but that's a common one. And then it does that from outside the process so that you can then dump those stack traces somewhere, and it basically doesn't have to require changes in the actual code. You can add stuff to the actual code if you want to, for example, tag functions or do something, a little more granular. But basically, as sort of a rule of thumb, you're able to get this information by just looking at the stack trace frequently and keeping track of what applications we're running and that kind of stuff. It can be slightly less accurate in some instances because of this method, but realistically, or I guess like from a practical sense, the way that people use this is it often ends up being frequent enough, or I guess granular enough, that it gives you what you want to know without having to the price that you pay for being slightly less accurate is that you're able to get more information. Okay, and so now I guess specifically how Pyroscope works. We use exclusively sampling profilers for Pyroscope. And basically we take profilers from open source profilers from a bunch of different languages. So for Golang, we use pprof, Ruby, we use RBSpy, Python, we use PySpy, which is what I'll talk more about later. And there's a bunch of other ones for other different kinds of profilers. And each one of them has a slightly different quirks to it or whatever. But at the end of the day, they all produce some kind of profile output. And then the Pyroscope server basically collects those profile outputs, and then the clients for each of these specific languages are all forked and adapted in a way where they have a session manager that collects the profiles every however many seconds, transcodes those profilers into a standardized format, and then sends those profiles to the Pyroscope server. And then the profilers are all of these that are mentioned here, where the session manager interacts with those over often a C API. Okay, so now I mentioned earlier that I would give a more practical example. So here's an example of showing how data gets turned into a flame graph. So in this case, let's say we just have a function. It's very simple. It just does a while loop that simulates doing work. Fast function works for 200, I guess, iterations, cycles, whatever you want to call it. slow function, or sorry, 20,000. Slow function works for 80,000. And so then if you do while true and then you do fast function, slow function, what would ultimately happen is the text form of those profiles would show up with something like server.py. Let's say that's the file that this is running from. And then fast function calls work, and then work works for 2 units. And then you have server.py with slow function does work for 8 units of time. And then you can see how that turns into a tree, basically, or just a kind of a tree-like data structure, which is a flame graph down here, where server.py calls slow function and fast function, which then each call work themselves. And so that's how you end up with a flame graph from actual code. And so, yeah, so again, with continuous profiling, if you just take all of that data and you, so let's say you're getting these profiles every 10 seconds or every second or any, frequent period of time. If you just take these profiles in their raw form and you store them anywhere, they're going to take up a lot of space, and over time they will accumulate and it will become really inefficient, to the point where the data that you're saving is not worth the amount of performance improvements you're able to get by profiling the data itself. So it becomes kind of counterproductive. And so in this case, these GIFs are written in Go, but I guess you can, it's more the general concept that are important here. But yeah, so basically what we do is we take these frequently repeated data structures with these stack traces, or repeatedly, we take these repeated stack traces and turn them into a tree, so that we can basically cut down on the repetition. And that is one optimization that we make for using them to compress the stack trace. And then even within the symbols themselves, we're able to basically, rather than saying net/HTTP request, net/io.read, net/io.write, you can picture here, we can turn that itself into a try, where we can basically serialize these symbols into a form where this becomes just 0, 0, and then you just store a dictionary separately, so that you're able to really just hyper compress all of this data, so that it's so that's really efficient, and that it, the storage doesn't become as much of an issue when you're storing all of these profiles over maybe a week or a month or a year's worth of time, sometimes for a bunch of different applications or a bunch of different once you add tags, this gets a lot more complicated. But basically, this principle of storing things really efficiently allows you to have a lot of room to store all the data you need, so that you can later analyze it and understand where your server's resources are going. And so, yeah, so then basically, once you have all of the data compressed really efficiently, the next issue becomes, okay, now when you want to query the data, it's all compressed, and how do you query it efficiently? So let's say you want to query a year's worth of data, and you're storing that data in 10-second time segments. If you want to query that, you're basically going to have to perform I think it's something like 3 million merges in order to get each 10-second tree into one giant year-long tree, or aggregated into one giant year-long tree. And so another thing that we did in order to basically improve that is that we basically use segment trees to store the data at different granularities. And so it basically turns that into a basically like basically a much more efficient operation. So here, instead of, so while we do store the data at 10-second increments, we also every 10 seconds or every 20 seconds aggregate two 10-second time blocks into one 20-second time block. And then every two of those, we aggregate that into one 40-second time block. And so you can imagine as you go up, doubling each time, it makes it much more efficient to where if you want to collect 50 seconds worth of data, now instead of having to merge 5 trees in order to get 50 seconds worth of data, you can basically just take one 40-second tree and merge it with one 10-second tree. And now you're doing one merge operation as opposed to 4 merge operations. And so basically that solves the query problem. So to summarize, it's like, on one side, you have the storage problem. Basically, by using trees and tries, you can compress all the data so that it's stored efficiently. And then on the other side, you use segment trees in order to query the data efficiently so that you're able to query it both quickly and cost effectively to be able to understand whatever query you might want to see. Yeah. Okay. So I guess the big question there is, so why profiling is important. There's a lot of major companies that are already using profiling in a lot of different ways. As you can imagine, Google has a lot of interest in understanding where resources are going. Same with Amazon or any of the big players out there. Netflix, if you've heard of Brendan Gregg, is one of the pioneers in this kind of space. And basically, there's a lot of statistics out there, especially when you're operating at higher scales, of how 100 milliseconds in latency in this case, Amazon said that corresponds to losing I think it's like 1% in revenue. And I think they have, so basically it comes out to, for every 100 milliseconds in latency that they lose $1 billion in revenue. And so understanding why their application is going slow or what functions that latency is attributed to is really important. And especially in making sure that their requests are faster and that they're not losing revenue. Similarly for Google, they generate 20% less traffic for every extra 500 milliseconds in latency. Uber has a bunch of metrics on this as well. And actually there's a lot of reports recently, as I'm sure many of you have seen, of Slack going down or GitHub having an outage. And a lot of those times, if you actually look through their postmortems, a lot of times they're talking about profiling as one of the tools that they use to help diagnose what went wrong and why. And that's just it's becoming a more important part of understanding, and particularly continuous profiling is useful because now you're able to go back in time and see what happened, as opposed to in the past, you would have to basically try to real time hook into your process or something, run a profile to figure out why it's hanging or something along those lines. And a lot of times by that point, you've already missed the important tipping point that caused something to go wrong. So I wanted to show, I've talked a lot about it, wanted to show kind of a real world example. And so in this case, we created a fake rideshare company, just think Uber or whatever, where there's 3 regions, and then there's 3 different like vehicles that you can hail using this application. And basically we use tags to tag each region separately, and then tags to tag each vehicle separately. And we actually, you can find this example in the, Pyroscope project on GitHub. Again, I'll share all these links out later. In this case, this is a Flask app that we're using for this example. And so let's jump into it. So yeah, so this is like what the Pyroscope UI looks like. And so yeah, basically here, we profile the Pyroscope server itself. But then here is the application that I was just talking about. And so yeah, what you're looking at here again is a flame graph. And you can actually see down here in server.py, you can see there's 3 functions here. It calls order bike, it calls order scooter, and it calls order car. And basically how, let me make this a little bigger. Basically how you read this for a profile is that typically you want to start with the nodes that are the biggest, are often the ones, are obviously the ones that are consuming the most resources. So in this case, this order car function is taking 70% of the time, while order scooter and order bike take obviously much less. And so the way you can use Pyroscope or profiling in general is you can actually kind of, as I mentioned, there were tags. And so in this case, a typical way that a company might tag something is you might tag it by, a region. So you could see US West compared to, I don't know, whatever, we'll say like US East. You could do US West compared to, EU West compared to US West. And yeah, and in this case, you can kind of see, so up here, you have the level of CPU utilization. And then down here, you have the flame graph associated with that. And so in this case, you can kind of see there's a pattern of a lot more CPU utilization for this US West period, and then less for this EU West period. And so you might, if you were profiling this, you might want to dig into, okay, why is the US West consuming so many more resources? In this case, I can tell you it is because we forced it to in order to sort of make a point here. So yeah, so somewhere in here, yeah, basically I just say, if the region is US West, do an extra function. But you can actually see that as well in this diff view, where you're actually taking the diff between these 2 flame graphs. And similar to how you would look at a diff in on GitHub or something, the green is code that was removed, the red is code that was added. And so in this case, between these 2 functions, you can kind of see, I guess, what the issue was. Yeah, so anyways, that's just like a quick example of kind of like how you might use profiling. There's also the concept of ad hoc profiling as well, where you can do, if you want to just profile a script or do something that isn't necessarily running continuous. But yeah, I guess that's generally how profiling works and what it looks like. Let me jump back into the slideshow here. Yeah, so yeah, if you can go to the link here if you want to look at the actual code for that. But yeah, one other thing I wanted to kind of go through was it was actually pretty tricky to get this into a pip package so that we could use it in Python applications, particularly so that we could tag specific things like I just showed in that example. And so basically, in order to make Python, so as I mentioned before, PySpy, although it profiles Python processes, it is written in Rust. And then Pyroscope itself, the main, I guess, like server-side code is written in Go. And then obviously we're trying to support, or we do support Python applications. And so we had to find a way to basically combine Python code, Rust code, and Go code all together. And basically what we came up with there is, so we have the, you just import Pyroscope, you do pyroscope.tag if you want to tag something. And so you call Python methods from your application, which then basically call this libpyroscope.so that connects threads with tags, uploads that profiling data to the Pyroscope server, and then and then PySpy itself profiles the whole process, and then all of that is all combined together and sort of a like I said, in a somewhat tricky approach. Over time, we want to kind of simplify this and probably, or at least get rid of the Go code. And I don't think there's not really a way to get rid of the Rust code in this case. But yeah, at least get rid of the Go code and do all of that in 2 languages rather than 3. But yeah, we combined all of those to make the pip package work. And so yeah, I guess also worth mentioning a kind of a problem that we're dealing with now as we're sort of working on this is that because of the way it's implemented, there's kind of this issue of where often Python programs are multi-threaded, or at least ones that are doing a lot of work, and the problem was that basically, if let's say there's like 2 requests and one is doing /foo, one's doing /bar, and so if thread 1 is working on the foo request and you tag it as such, right now the profiler kind of tag state is global, and the problem is that if you get another request and you tag it as bar, then you end up with this kind of mixed period where where it essentially overwrites the foo tag, and now there's work being done in the foo thread still, but it's now being labeled as bar, and so it's like a little bit mixed. And then at the end, once foo is done, it will remove the tags from if you're tagging that particular request or whatever it is. And then the issue there is now it's removed the tag, and then you have the rest of this bar thread that continues running, and then you're going to miss out on some of the work that's being done there. And so one of the things that we are doing there to basically make all of that work, this is a pretty complicated diagram, so I guess I won't spend too long on it. I guess the important part here is that we've added this ability to add a tag that is also including the thread in that tag, so that we can then basically do some filtering, add a tag to the thread in addition to the whatever tag you may have set from your Python code, and then basically send all of that data, do the work that it's doing, remove the tag, and then send all of that data to thread specific buckets where we can then basically do any like minor, I guess, like aggregations or whatever we need to do there on a thread specific level, and then be able to send that back to the session manager so that we can do that. So that in the end, it looks up going from this version on the left, which is the version that I just showed, to this version on the right, where there's it no longer has a global state, but each thread has its own sort of separate bucket and its own separate set of tags that then allows you to to make this work for bigger Python applications. So I guess that's kind of, I know I went through a lot of information quickly. Something that we're kind of working on for the future for this too is that the thing about the way that we collect the information is that it is all sort of like it's not necessarily specific to any language or type of profiler, but rather just that an agent or integration can export the data in this format or in a format similar to this. So one of the things that we're trying to work on moving forward, particularly for a lot of Python people, is doing this for for like GPU profiling, which is something that a lot of machine learning people have started to use more to understand Yeah, like during machine learning workloads, what is consuming a lot of resources. Same thing with memory profiling for Python. That's something that we are actively trying to find, I guess, yeah, working with various people in Python community to try to figure out how we can do that in a similar way, or in an efficient way, I guess I should say. And so, yeah, there's a lot of stuff that we plan to do with this moving forward in the Python world. TensorFlow, I know, has its own profiler that would be able to format data like this and send it to the Pyroscope server. And so long term, we kind of want to make it something where no matter what profiling data you have, you can send it to the Pyroscope server, have it in just one central location, and be able to analyze it and use all of the fancy features like the diff view, the comparison view, tags, whatever it might be, and be able to, I guess, use profiling efficiently. Yeah, so that's all I got. Like I said, I know I went through a bunch of stuff pretty quickly. Would love to answer any questions if people have any.
I have two, but I'll start with one.
All right, go for it.
The hard one. So profiling usually takes some resources itself, but there are different ways of profiling typically. One of them is kind of like random. The other one is like you record everything that's going on. I assume you're taking, because you seem not to be affected by performance, you're probably using the random method. Will you think about switching or anything, or allowing both, or like, well okay, open up and tell what you think about
Yeah.
it.
Yeah, so yeah, there's multiple kinds of sampling that can happen. So but yeah, so the one that we used for the like Pyroscope Python integration is a sampling profiler, and the way it works is it just looks at the stack trace 100 times per second, and that way that's a very inexpensive process and can then report that back. I will say a lot of I don't know, I guess off the top of my head which ones do which, but I do know a lot of the Python profilers do it in the other way that you mentioned, and so yeah, the way that we do it, there's like roughly like 2%, 2 to 3% overhead doing it that way. But a lot of the other profilers, the way that they do it is that they basically, yeah, hook into the method invocation basically wrap every single function in some like profile this code. And when it does that, it has to, run that line of code, do the profiling, run the line of code to stop it. And that tends to be higher overhead, like sometimes like 10% plus. And so that's fine if you're just, profiling a script, for example, and it doesn't matter if you add a little bit of overhead. But in your production application, that is most likely going to be a issue for most for most production apps.
So you mainly aimed at production. That's why using the sampling method.
Yeah. And really, honestly, you can use the sampling method just as effectively, in development as well too. So a lot of ways that we've seen people in like Python world use this is for like profiling test suites, for example. And in that, you can use the ad hoc profiler, which still uses the same method of getting the profiling data, but just does it, for a fixed period of time, as opposed to profiling your server constantly. And so, yeah, maybe your test suite or a script or maybe like a batch job or something like that, you can use it for either, really. So I guess, yeah, what I'm trying to say is you can use sampling profilers for pretty much everything, but you can't use the sort of like traditional high overhead profilers for everything, particularly production.
Okay. So unless if someone doesn't have another question, I have another one, but let's give someone else an opportunity.
I have a question.
Go for it.
Did you have any trouble when using Rust? Because I know Rust is, I know some people say that it's like a newer language. So I was just kind of curious because I want to learn how to use it. So I was just kind of curious.
Yeah, I'll let Dima, or yeah, so Dima, as I mentioned, he's in here too. He handled the Rust side of things. Yeah, you can definitely get deep in the weeds there. I guess, yeah, you want to talk about sort of like why, I guess, yeah, why would you say, Dima, that that PySpy is written in Rust, and yeah, what was your experience working with it?
So I think it's written in Rust because that allows the profiler to kind of not be constrained by the Python GIL, what is it, global interpreter lock? And so it can do profiling in a separate thread and not block the actual program. So that's very important. And I think that's why they went with Rust for that profiler. Experience of working with Rust, I would say, just kind of like writing code and building things has been pretty, I wouldn't call it straightforward, but it was a good experience. The tooling is very advanced at this point, and the compiler is very friendly. It gives very good error messages and things like that. I would say one part where it was kind of tricky and where we didn't have quite as much tooling is the part about kind of connecting all of those things together. The slide Ryan showed where we have a Python module, and inside of it is like a Go module, and that module links to a Rust module. All of that was tricky to set up, and we plan to kind of simplify it a bit to go with yeah, just one language, like Ryan was saying. And yeah, there's not a lot of kind of existing tooling to make that easier. So we had to kind of write a lot of extra code to like build wheels, upload them to PyPy and things like that. That was kind of tricky. Yeah.
Pretty cool that you're using Rust though. That kind of surprised me. I was like, wow. That makes sense. I think so. Like, is that kind of to speed up the threads, right? Because
yeah, so that because if you do it in just a Python thread, I think the context switching overhead and things like that will just slow it down enough that the overhead will just be too high.
I see. It's pretty cool.
Yeah.
Can you explain how you would utilize the Pyroscope as an agent of change for an expansion, measuring key performance indicators for a market, for a business, quarterly report, for example?
Yeah. Yeah, I mean, that's like a great use case for Pyroscope. Let me see if I can pull up a good example here.
Thank you.
Yeah, so let me share my screen again. So yeah, we also have like a demo page here that we've had running for a while. Let me see if I can find a Python. Let's see if this one's, yeah, so, okay, so yeah, here's an example. So this is a Python application. It's not a particularly interesting one, unfortunately, but we started this demo application on August 31st. And so basically this profile right here tells you over, the time listed here is slightly deceptive because sometimes the application isn't actually doing anything. So even though this says 2.4 months, it's actually obviously more. But basically, this is telling you over this entire time period, where was your CPU utilization going? And so one example of a way that, so not only could you use this for like budgeting purposes, to essentially correlate your level of CPU utilization to the amount of servers that you needed. So let's say this is 100 servers, and you're like, wow, we're spending a bunch of time in, in Jaeger reporter.py or whatever it is. And you can say like, oh, if this is 25% of our time consuming the queue, maybe if we can get that down to 15% of the time, now instead of needing 100 servers, we just need 90 because we've relieved ourselves of 10% of, of whatever we were doing before. So that's one example. Another example is just, in general, using this to catch a lot of waste, where you're wasting a lot of CPU cycles. So a lot of times that happens in serializing and deserializing things, or sometimes what we find a lot of times where the first time people try this is that they realize that logging is consuming like, 20% or something crazy of their CPU utilization. And so there's a lot of things like that where you can basically factor this into, you can tie this to direct sort of cost savings for a particular organization. And so that's one example. Another thing that we want to do long-term though is also be able to, you can imagine, if you have, this isn't divided up into like, so this, for example, so like requests, API.py. So let's say, Johnny wrote this code and Susie wrote this code. You could also, one of the things we want to do is be able to basically go from line number, basically go from like get blame of this function, this line number, and be able to show you sort of like on a team perspective, sort of, who is writing the code that's consuming the most resources. Not necessarily to blame them, but also just to understand from a different angle, sort of, another way that you could potentially reduce code is if someone is, consistently writing code that's consuming a lot of resources. It might be the nature of the code or the nature of the person. Either way, good information to know as you plan for your team. And I don't know. So there's a lot of use cases like that, as I mentioned as well. Doing it for test suites, which also often are the culprit of consuming a lot of developer time, waiting for tests to run. And you can see, oh, these tests are taking forever because of blank. And, the more we speed up the test suite, the faster we can deploy. A lot of companies measure like, like mean time to resolution. You can use it for that, being able to see, how fast you're able to fix issues, all that kind of stuff. So there's a lot of ways. You have to get a little creative for now, but we plan to add more of those into the kind of make it easier to make the jump from a flame graph to some of those metrics that you can tie to sort of, quarterly reports or whatever it is. And we plan to add more of those over time.
Real good, thanks. I have a friend up in Ohio, and it's trends are moving more for automation, and that's where explaining process calculus with your analytics, what you can offer. It's just how to integrate it into reports between engineerings and accounts, and saying, okay, this is how we can make the whole everything work better.
Yeah, that's a great point. We do have a Slack bot that we created so that if you like post something in Slack, you can, if you post a script in Slack, you can profile it. We internally have built a version of this where for every PR, it does run the PR against a baseline. so that you have a diff. Not only do you have the diff of the code that changed, but you have the diff of the flame graph between the code before and the code after. And so I think that's kind of along the lines of what you're saying, that those types of things you could put into reports and share it between, like engineering and accounting, to understand both, where all the resources are going and where you can save money and time.
And data driven, and then you have everyone on council to say, here's your decision.
Yeah, exactly. Yeah.
Great.
Yeah,
Thank you.
great point. No, thank you.
So Ryan, what would it take to make this work in a Kubernetes cluster, or have you seen this implemented in a Kubernetes cluster?
Yeah, so it works great in Kubernetes. Actually, I would say that's probably the most popular sort of or one, maybe not the most, it's up there, but yeah, it's a very popular way to use it because actually we have pull mode for some languages, but basically there's push mode where you're pushing from your application, and then there's pull mode where you set a bunch of targets, and Pyroscope can then pull the data from those targets. When using pull mode, the benefit of that is that you can actually basically tag all of the important, and I mean, you can do this in push mode too, but you can tag all of the important, you can automatically tag all of the important parts of Kubernetes. So pods, containers, namespaces, and you can break things down by what is actually a pretty natural way to break up a Kubernetes application, or to dissect and analyze it. And yeah, I mean, honestly, it kind of just works out of the box. You'd have to add a little bit of add a little bit of code to tag things the way that I just mentioned. But otherwise, yeah, it works in Kubernetes workloads really well. And that's actually another great example of often in Kubernetes, it's easy to get into a bad habit of just like getting more pods or more resources to do whatever you need to do when when something is consuming too many resources. A lot of times the answer is like, oh, well, let's just bump up the number of pods or number of containers or whatever. And this helps you potentially go the other direction and say like, oh, actually we could go down, or at least stay the same, and understand why you need to bump up if you do.
As far as the implementation, like you just have to add, like, let's say you have a Python service, or and you just add that import. Like how is this going to be? Like, can you give us like a kind of like a? I know you talked a little bit about it, but how is it implemented? But
yeah, let me just go to docs page.
Yeah, the gist is that you add it as a pip package, the same way you would add any other pip package. Yeah.
And how does it talk to the server? You just have to say, okay, here's my like the endpoint for the server, and it's gonna do either pull, or you said it, or push, but yeah. So, okay, I see. So server.
Yeah, so you just set the server address, you set the app name, wherever you're running this initial code, which let's see, let me go to Pyroscope, examples, Python, sure, Flask. So yeah, so in this case, if it's like a Flask app and you have server.py, you just run this, just import Pyroscope. You configure it at the beginning. In this case, since it's in Docker, there's basically a Pyroscope service running, and then you just set the server address. Here I set tags as a I set region as a static tag. So that's an example of a static tag, whereas you can also setting dynamic tags looks more like this. So you just say with Pyroscope.tag wrapper, And then basically all of the code that happens in here will have this particular tag. And yeah, in this case, you pass in either car, scooter, or bike, and then it will tag it there. So you can either do, so yes, that's kind of what I was mentioning with dynamic tags here, but yeah, for Kubernetes, a lot of times, yeah, a lot of this stuff you can do as static tags when you first kind of initialize the initialize Pyroscope in your application.
Oh yeah, and probably it's a better idea to like use some kind of environment variables, you know, inside your cluster, so you don't have to
Exactly.
you have it to change your your like server address. You don't have to change all your code. So probably that's
Yeah, exactly.
cool. Well, looks pretty cool.
Can I come back to my other question? Do we have time?
Yeah.
Okay. So, how did you get to do this? I'm curious. It's like the profiling is not like the very typical. So what drew you to it? How did you get to do this?
Yeah. I'll let Dima talk some about it. But yeah, basically at a previous job, we had used profiling a lot, and there was a couple of situations. Like there was one particular situation where we were doing a bunch of compression, and we kind of built a hacky version of what is now Pyroscope to kind of figure out, like, you know, things seemed a little fishy, and we were like, I don't know, you know, why things are consuming so many resources. And so yeah, there was, you know, it was doing a ton of compression, and we realized that that was taking up, like, I think it was like 40% of the CPU. And after we looked into it a little more, we were like, that we don't mean for it to be that, we don't need for it to be that compressed or mean for it to be that compressed. We found out that just like there was just a parameter, like by default, it was set to the maximum level of compression. We literally changed like one line of code, and we saved, like I said, like actually like 30% on our AWS budget for the rest of the, you know, forever into the future, I guess, until some other weird bug like that entered. And so, yeah, we were like, wow, this is really cool. It's crazy that we had to like hack this together. It would be awesome if this was a tool that like existed that people could just add to their application. Yeah, Dima, do you want to, I guess, add anything there?
That's a perfect explanation. Yeah, we just saw a lot of potential in profiling. We used it a lot with that compression example, and with a bunch of other things. We profiled all sorts of batch jobs, web servers, databases even, and we just saw it as like a very powerful tool that didn't have a lot of good kind of tooling around it. There's a lot of like scripts or a lot of like projects that you have to you have to put together everything yourself and wire it together to make it work. And yeah, we just thought it would be cool to have it all be kind of figured out for you. You just install a package and you get all this information
Yeah,
over time. Because yeah, like another thing that wasn't a thing before is you would have to like you could only profile on ad hoc basis. So like if you had an incident or something like that, you would have to like reproduce that incident in order to get the profiling data. And we thought that, you know, it would be nice to also just do it 24/7 so that you would always have the data.
Yeah, I was just gonna say, like, what are you saying about the scripts? Like, this is how we were running it before. You know, you have to like, you know, run this and then pipe it into that, and then pipe it into that, and then you know, make it into a file, and then open the file in your browser. And it was just, it seemed like, you know, all of this could be much simpler. And so and even that doesn't even work on like a continuous basis. That's just to, you know, profile something, you know, like right now. And so then yeah, we thought that there was a lot of, and we thought it would just be a fun project. I think people often sort of talk about logs, they talk about metrics, traces have become slightly more popular. And now kind of profiling, I would say, is kind of entering that sort of like realm of things that that people are using as part of their sort of toolkit in as they're moving often to more like cloud native workloads and that kind of thing.
Thank you. Cool.
Yeah, very useful. That's kind of amazing. I mean, you can do it 24/7. That's actually so powerful. Like the fact that you can practically take a look what happened instead of just telling the profiler when after the fact. That's very that's definitely super useful.
Yeah, and even that example I showed with the demo that went back to August, you can still go back to any 10-second time period in August and see the data. It still loads really fast because of that, the query stuff that I mentioned. And it's obviously we're biased, but we think it's pretty cool.
It's not just pretty cool, but it's actually useful. Like you told me that you can go back and you can practically see what happened instead of actually reproducing it. And that happens so many times. Like, okay, well, it's kind of like one of those things. You worked on my machine, and
yeah, exactly.
But then it never works when you try it out.
Right.
Cool.
It always, the thing that you want to happen, it's like always when you're looking away is when it happens. And then you're like, damn, I missed it.
Yep.
It does seem like an excellent tool for profiling. I think I was thinking more for marketing, and you just set up a machine learner for it. And that's where I can envision having just an incredible amount of utility.
Interesting. Yeah, I guess I haven't thought as much of it from that perspective, but I mean, I think that's like the cool part about this is that, there's a lot of different routes that it can go.
Thank you.
Yeah, thank you. Yeah. All right, cool. Well, I guess if there's not any other questions, I appreciate you guys taking the time to listen to us ramble for a little bit.
Oh yeah. Thanks so much. There's a lot of fun and definitely like very useful information here. Well, definitely personally, I'll take a look at it. So yeah, thanks so much, Ryan and Dima. Thanks for coming.
Thank you for having us. This was great.